Do you see something here?
There's a slight what? It's just a witness mark.
What?
Some guy, like, it's a, you know,
Random.
it's above the surface, right? So when they finish the injection molding part,
Yeah.
then they open the mold, they got one straight come out, then it ended up there.
Oh.
That's why.
Damn, I thought it was like me. You have to guess the material. No, but it's the same as the others. Unless this part got some stem. No, I don't
Yes.
think so.
Yeah, bring it closer to you, no need control.
Nah, got no. You only can guess what the material is.
We can burn and smell it burning.
Burn?
Yeah.
You want burn the thing?
Or you can feel. This feels like polycarbonate. I can bring to my friend's that he does injection molding design and he's in charge of material. And very easy
You
second.
already know what then you know what's the material.
Okay, so next I'm gonna take apart the main control board. This takes in 5V, charges a battery which we haven't soldered, which isn't soldered, and controls the fan. The fan is using a two lead wire only. It should be brushless. There should be more circuit on the fan side. But it's using 2 leads, so there's no PWM signal like the conventional mass-produced fans in the computer fan and stuff. You see, each operation can save like 3 seconds if you use electric. Yeah, show the thing here. Okay, with the fan board, there is 2 tactile click buttons on the top surface, and a battery percentage meter and a fan speed meter. 8, 9. Wait, this is how many? 1, 2, 3, 4, 5, 6, 7 segment plus 2 more segment LCD here. Eye catching features on the board. There's no markings on the chip here, so I have no idea what chip it is. I see how high the resolution. Wait, we shouldn't care that much about the electronic part, right? It's quite high. You could see like the each resistors, right?
Hey bro, I don't know.
Later we just 4K put on the screen. 4K for YouTube. Okay, the main circuit board has been disassembled. Next, we shall analyze the buttons. These buttons, this was originally this way. There's 2 holes here and self-locating dowel pins injection molded into the part. So the operator probably has to do it from top down because there's no glue or anything holding it into place. And then after everything was wired up, he flips this cover around and cover it up. If not, this button will fall out. So that's another part that could be part of the design, like if they just cut a keyboard here, so we can get rid of another part. Maybe this part's made of the same mold. Then next part, the base is attached to the, what do you call that? The base to the stem. Let's call this the stem using one single PH00 screw, self-threading into plastic. And there's another part here. Oh, there's actually a square profile. What do you call that? No, how do you describe this square? It's a profile, square, cut, indent, Robertson.
I don't know, just call it indent though. I don't know.
No, it's just a square it's not a circular profile, it's a square profile, so this thing can resist all the torque. So this feature will make sure the screw doesn't unscrew itself after you do this 50 or 20 times. See, no need 10 notes to record video, right?
Yeah, sure.
Yeah. Oh, fuck, it go one track itself. Okay. I just assume all the screws the same. Then the operator has to thread the wire through this gap in the hole, and the alignment is well, it's better still 360, because if not the display it will be behind the fan. Alpha also 360. Then this feels like it might be a separate part, but no, it's actually part of the same casting. Oh, but this is a separate part. You see the half transparent LCD display is glued into there. So this piece of polycarbonate is another part that you would just don't have over there. Who needs a display thing? Okay, I don't know how many part count there is, but let's keep disassembling. This feels like a separate part. Maybe I can remove it. Nope. Oh, there we go. This washer is a separate part. This alpha is 180. I think this feature is useless. There doesn't seem to be anything that this lights on. This is probably where the spill comes from, where the molten plastic goes into. So this alpha should be 180, beta is 0. And then now we have a true hole. Oh, how they make this part? This, they cannot injection or hollow part that looks like that. So as you can see here, there is a gap here and gap here. So we try to do the safe thing, not use the freaking. Is it recording actually?
It is.
We use the spatula. Yeah, here.
What are you looking for?
We can use a spatula. Yeah, I think this would
Try
be good. No clearance.
Holy shit.
I think it's like. Okay, we just use dangerous. Oh, can we push it from inside? No. Well, we can do some dangerous stuff. No, if I jam the piece in here, then it can come out. But yeah, obviously this design is very here. Okay, we have to resort to use a more dangerous tool. But before we use a sharp tool that can slice our fingers, we should use the thinnest flathead we have over here, which is 1.5. And we find out exactly how thin it is. Seems to be 0.3 mm thick. 0.37 mm thick. And then now we should be able to pry this.
Put your finger, bro.
Yeah. Okay, we're making this fan look so okay. Oh, that was the double pin right there. That's why it's so hard to pry. Like.
Oh, no wonder.
And then we can use these two to pry it away. So there are 3 self-locating pins. I thought it's like, interface free on the edges, but no, it's 3 double pins. And if you want to do this one step further, we should get some reference double pins of a known diameter. They have it all the way down to 0.1 mm, and then we shall measure this. This is 2.56 mm. We don't have a micrometer to measure stuff, but this is 2.51. 2.52. So they use a different size for each of the double pins. Interesting. Who came up with this design? 2.56, 2.56, 2.53. So that's another part. What do you say?
No, maybe it's the tolerance.
No, it's
purposely.
every part should be the same.
10% battery remaining.
How many?
10%.
We can argue with it.
You want me pause the video?
No need. Video sketchy setup.
Oh, you have? Oh. So long? What the hell?
This is the fake bell. This is not supposed to be made. You're not supposed to make an IEC to the female thing. No, like one time I was fixing a charger power supply with the terminals. Then we didn't communicate at all. Then I was plugging it in while my friend was unscrewing the terminals.
Holy shit, bro.